In this example, we want to identify the interval of continuity for this piecewise defined function. This function has two pieces. When x is less than or equal to 0, it is quadratic function. And when x is more than 0, it is a line. So this is an example of piecewise defined function. You can easily graph this. There's nothing complicated about this graph. When x is equal to 0, the quadratic part becomes 1. When x is negative 1, it becomes 2. When x is negative 2, it becomes 5, and so on. So let me use a different color for the left-hand side. So this is your x squared plus 1. And when x is positive, you get 3x plus 5. So if you plug in 0, you have 5 with an open circle. When x is 1, you get 8. So the line is going to be an increasing line. And again, note that I used an open circle here for you. We get 3x plus 5. For this function, the point that makes it complicated, the boundary point in this case, is going to be 0. The value to be discussed is 0. Why is that? Because at 0, the function is divided into two pieces. Because at x equal to 0, the function is divided into two parts. So we need to find the limit at 0 from left, limit at 0 from right, check to see if they are equal to each other or not. Check continuity conditions at A. So first of all, A is in the domain. This is the very first condition that we check. So is A in the domain of the function? Yes. 0 is in the domain of the function. 0, this is the first condition, is in the domain. There is no doubt here. 2, you need to check to see if the limit of the function while x approaches A exists or not. What's the meaning of that? It means that you need to check to see if limit from left is equal to limit from right or not. That's the meaning of the limit exists. So limit of the function as x approaches to 0 from left hand side, x approaches to 0 from left hand side, we are on the quadratic function. It's going to be the limit of x squared plus 1 as x approaches to 0 from left. Well, this is just simple substitution. Why is that? Because this function is a quadratic function. By substitution, you can easily see the limit from left is 1. Now for the limit of the function from right hand side of 0. When you're getting closer and closer to 0 from right, you are working with this line linear function. This is the limit of 3x plus 5 as x approaches to 0 from right. But again, here you have a linear function. Simple substitution gives us 5. So basically this is 5 and this is 1. So obviously they are not equal to each other. What's the meaning of that? It means that the limit at 0 doesn't exist. So the second condition is not met. So since the limit at x equal to 0 does not exist, we don't have continuity. You can basically see the function is jumping here. It was here and then it jumped right up there.